Kia ora Year 12. This video is going to start going through last week's exam for Pure 3. So most of the questions, as you know, were from the March 2018 paper. I'm going to start with questions 1 to 3. So question 1 was a trapezium rule question, which was reasonably well done. A little bit of muck up about figuring out the width of each interval. That put you wrong. The second question was very well done, which was a binomial expansion. That was pretty straightforward. And then question 3 was just... I'm laughing because some of you took a page and a half to do this proof. Now, some of you got there after a page and a half, but it was actually only about 4 lines. So we're going to have a look at the fastest way to do that proof. And then once you've done that proof, or even if you hadn't done that proof, this equation was reasonably straightforward to solve, but we have to watch how many solutions we're going to get. Okay, so let's start with the trapezium rule 1. Just notice that the function that we're integrating is the square root of 1 minus tan x. Not just 1 minus tan x, and 2 very strong students missed that square root sign, right? And that square root sign goes over the whole of the brackets. So when I do trapezium rule questions, I like to set it up with a table. We're going to have x here, and we're going to have f of x here. And in this case, f of x was root of, was it 1 plus tan x? No, 1 minus tan x. 1 minus tan x. Now we're integrating between 0 and pi on 4. So here's 0 and here's pi on 4. And if we want to have 3 intervals, that means that we're going to have 4 values, right? And each interval is going to have the width of pi on 12. So that means that the ordinates, or the x coordinates that I need to put in, will be, well, 0, pi on 4. And then the 2 in the middle will be pi on 12, and 2 pi on 12, which is pi on 6. And if you plug those values of x into your calculator, you'll get out 1 for this one, 0 for this one, and then for pi on 12, I got 0.8556, and for 2 pi on 12, I got 0.650115. And now we're good to go with our trapezium rule. So just remember that the trapezium rule tells us this. The area is roughly equal to the interval halved times this. And that comes directly from my trapezium area formula from back in Year 9, right? I've got half of these two times the height. And the 2 here is because when we have the trapezia joined up, we get this wall of the trapezium in 2 trapezia. I'm telling you that because you know you don't get the formula in the exam, so it does help to have a wee bit of intuition for it. So h in here is my width, which is pi on 12. So half of pi on 12 is pi on 24. That was probably the biggest mistake that you guys made. So here we've got 1 plus 0 plus 2 times 0.8556 plus 0.650115. Putting that all together gives me pi times, the brackets gave me 4.01143 over 24, which got me back to 0.525095, but we want that to 3 significant figures, so the answer is going to be 0.525 to 3 sig fig. Okay, let's look at this next one. All right, now this question had some people, most of you did it really well, but some of you just skipped over the basics and need to do some major revision on the chapter on binomial expansions, which is the very first thing that we did this year. The first thing that we're going to do is we're going to rewrite that with a fractional power and then see if it's in the right form. So we've got 1 minus 4x to the power of 1/4. And we need to have it in the form 1 plus x to the power of n. So we're just about there. We can rewrite this as 1 plus negative 4x to the power of 1/4. Now, once we've got it in the right format, the formula that's going to help us is this: 1 plus nx plus n times n minus 1 over 2 factorial, x squared plus n times n minus 1, n minus 2 over 3 factorial times x cubed. And the x here is this x. So in our case, it'll be negative 4x. Now, some things that concerned me that I saw in here is I saw some really weird stuff. I saw some of you writing things like 4 choose 1/4. So this combination notation that we use all the time in stats just does not work for fractional and negative powers. That's why we're doing the kind of written out version of the combinations. Pens just stopped working. What's there? So this is how we should be doing it, right? So let's start substituting in. And here we've got this. We've got 1 plus negative 4x to the 1/4 is roughly equal to 1 plus, right, let's go really slowly. N is 1/4 times negative 4x plus 1/4 times negative 3/4 over 2 factorial times negative 4x squared. We need to do one more. It's going to be plus 1/4 times negative 3/4 times negative 7/4 over 3 factorial, which is 6, times negative 4x cubed, right? I couldn't believe how many of you were trying to do those calculations in your head. A couple of problems with that. First of all, you'll miss out on a method mark. And secondly, you're really, really likely to screw it up. So just try and slow it down a bit. So here we've got 1. Check your signs carefully. We've got minus x. And in here, we've got, let's see, we've got minus 3 over 16 times 2 times positive 16x squared. So you can see that that's simplifying away. And then here we're going to have plus 21 over 6 times 64, 4 cubed, times negative 64x cubed. What does that give us? Well, we get 1 minus x minus 3 over 2x squared. And in here, 21 over 6 has got a common factor of 3, so it's going to be 7 over 2. It's going to be minus 7 over 2x cubed. And that is my final answer for that one there. Okay, we weren't asked for coefficients or anything weird. We were just asked to do that expansion. And in this case, there was nothing after that. We didn't need to integrate or solve. That was it. But often, if you muck this basic expansion up by going too fast, you're going to lose yourself not just the 4 marks, but the marks that come after it. Anyway, right, okay, on to number 3. So this proof one, this is all we've got to show. All right, we've got a fraction, and we have to show that it equals 2 cot 2x. So let's think back to year 9. What did we do when we added 2 fractions together? Well, we got a common denominator, and that's where we're going to start here. So we're trying to get to 2 cot 2x. We're starting with this. So almost all of you, instead of doing that, started by expanding out this and expanding out this. And yes, you got there, but there was quite a bit of extra work. The fast way to do this is just to get a common denominator and say, well, we've got sine x cos x. And now we're going to have cos of 3x times cos of x plus sine of 3x times sine of x. Right, let's look at the denominator. This is half of sine 2x. This is my compound angle formula, and it's cosine of 3x minus x. Right, and if you want to go out the side and write, since cos of a minus b is equal to cos a cos b plus sine a sine b, you could do that, but I don't think you needed to. The other thing that could happen in here, so I've done this, when you do it this way, you'll see straight away we get cos of 2x over 1/2 sine 2x, which is 2 cos 2x over sine 2x, which is 2, oh, stylus has gone weird, 2, just a sec, don't know why it's done that, sorry, thanks for keeping watching. Right, where's it gone? Hopefully it's going to come back. Well, that was very weird. Okay, sorry, that's 30 seconds of your life wasted on waiting for OneNote. Now we've got 2 cot 2x as required. I just want to point out one thing that might have thrown you in here. If you happen to have done cos of x, cos of 3x, then in here, this will make sense hopefully to most of you. In here, when you've done that workup, you would have got cos of x minus 3x, which is cos of negative 2x. But then from our working trig, we know, because it's an even function, that that's equal to cos of 2x. Okay, so that's the proof done. And then all we've got left to do in the last 4 minutes of video is we have to solve an equation using that. So we had to solve this equation. So even if you'd screwed up the proof, clearly what you're expected to do here is to use this result here and say, well, this is a nightmare, but we can replace it by 2 cot 2x. So all we're solving is this. 2 cot 2x is equal to 4. Cot 2x is equal to 2. We don't like cot of 2x, but we know that it's 1 over tan 2x is equal to 2. That gives me 1/2 is equal to tan 2x. Okay, I can't stand this pen. I know that some of you can't stand it either. Now, if I'm going to do that with general solutions, what do I get? Well, alpha is equal to tan inverse of 1/2, which gives me 0.4636. So 2x is equal to 0.4636 plus n pi. So x is equal to 0.232 plus n pi on 2. And so substituting in values, the first solution that I'm going to get is x is equal to 0.232. But there is a second solution, which is that x is equal to 1.80 from adding pi on 2. Now, if you're not sure how to spot that you're going to get two solutions, you can see that we're working with tan of 2x, and we were told that x was between 0 and pi. So just working that inequality through, timesing everything through by 2, then what you'll see there is that 2x is between 0 and 2 pi. Right. Okay, so that's all I'm going to do in this video. That's the first 3 questions done. Hopefully that helps a wee bit. I'm going to work my way through the 10 questions and the stats paper over the next few days. And I will also have a wee look at it in class with you. Thanks for watching.